This is The Science Behind the Soldier, a podcast from the Combat Capabilities Development Command Soldier Center.
Hey, first of all, Happy New Year to everybody, and welcome to our second podcast. Today, my guest, or our guest, I should say, is Eric Campagna. And we're going to talk about a small unit resupply. And so, but first, I want you to introduce yourself, right? Talk about a couple things, right? Your background, and then what kind of brought you to the Soldier Center, if you could.
Sure. All right. So, good morning, sir. My name is Eric Campagna. Like you said, I am the currently branch chief of Airdrop Technology Team. A little bit about my background. I'm an electrical engineer. I think one of the questions we were going to discuss initially was why the career choice for engineering, why I actually went into it. First, I think it was a combination of, how I grew up and a little bit of schooling. So in general, I'm from Western Massachusetts, from Pittsfield, Mass. I grew up in a family that was very hands-on, did a lot of work ourselves versus, going to a specialist. So I think that introduced me to problem solving, as a kid growing up. Then from school in high school, really only enjoyed mathematics. All the other subjects I didn't love. So senior year, once we started applying for colleges, I had to make a choice on what I wanted to major in. And I knew it had to be related to math. I knew one or two engineers seemed good, seemed like I'd enjoy the problem solving. So I just checked that box and started applying for schools. So I kind of just lucked into it because I do enjoy it today.
Yeah.
So from there, I actually went to Roger Williams University, graduated in 2005, electrical engineering degree. So a little bit, after graduation, I actually got a job immediately with the Soldier Center.
Did you do a summer hire, or was just immediately after graduation?
So the way I got introduced to the DevCom Soldier Center was one of the other divisions sponsored our senior project. So our senior project was to develop our team of 3 students, was to develop a boats fendering system. So the command, basically the control unit for an automated fendering system. So basically we developed a control system that inflated a fender, monitored the pressure, and detected leaks, and then deflated once you pull away from the dock. We did that. That's how we got introduced to this. So that's how I got introduced to the Soldier Center. From there, graduation, I ended up applying. I saw a job opening for aerial delivery, applied to that, and was hired immediately after graduation in 2005.
Fantastic.
Yep.
Was that, just a real question, that tender for the boat, was that the precursor for the air beam tent technology?
Yes, it was. Yeah. Yep. Absolutely. It was the air beam. We were using that. We had a surrogate fender. Mm-hmm. And then basically our side was the whole control unit, right, that did all the detection of the inflated, deflating, and that type of thing, monitoring pressure.
That's awesome.
Yep.
Hey, so let's talk a little bit about small unit resupply, and I just wanted to make sure that those who are listening to this podcast understand how hard it is for a small unit, the flow of supplies down. I mean, it doesn't happen automatically sometimes, right? And there's different types of supplies, right? There's 9 classes of supplies for the Army. But what soldiers are most focused on, obviously, are food and water, ammunition, and medical supplies. That's really what they're most concerned with. And then getting to a small unit is a very complex process, right? Starts at very high distribution levels, works its way down to division, down to brigade, to battalion, and then to the company and platoon and squad level. So it's a lot of flow there. And there's no automated process in that really right now. And so your team's trying to help solve some of those problems and actually get equipment to the soldiers when it's needed, which is in tomorrow's combat. It could prove to be very difficult, particularly in some of the areas that we have to go in, right? Indo-PACOM, different theaters in Europe. But Indo-PACOM has challenges because we're going to have units dispersed across 22,000 of the islands out there potentially. So anyways, so I want you to talk a little bit about what you guys are doing and what the team's doing to help solve that, if you could.
Sure. I'm one of 3 S&T teams in the aerial delivery division. In general, we have a lot of experience over the course of the last, call it 10, 15 years. We've fielded a number of S&T systems and programs of record within the PM office that are getting after emergency resupply from both, high altitudes and high offset emergency, resupply at the tactical edge, right? So we work a lot. So we basically have, our thrust areas are kind of heavy drop, which are a lot of weight coming out of the airplane, and then the small unit stuff, which is small amounts of supplies in austere locations going over long distances. So we have experience on autonomy. We're working on the vehicle side, which from the experience on the high offset systems, high altitude autonomous systems, now we're because of the distances we're talking about in the future conflicts, we're adding power to those systems to get longer distances. In addition to vehicle development, we work a lot in mission planning. That probably evolved because legacy airdrop used to be unguided. It wasn't controlled. So mission planning was the method of making resupply accurate. You had to really have great models of your resupply vehicles, understand weather, and drop it in the correct location. Now our systems are all guided. Some of them are guided, and they will make themselves more accurate even if they're not released in the correct place. So that's vehicle development. But with mission planning, we're starting to evolve a little bit in a new area project that is called small unit resupply, like you kind of introduced. So the purpose of small unit resupply is to kind of accelerate the emergency resupply response time through automation and information exchange, and then facilitate automatic decision making at the tactical edge. The reason why this project exists is like you said, the future battlefield, and why it's important is it's really aimed at the future battlefield. Adversary, like you said, is going to have more capability than those that we fought in the past. So some of from an emergency resupply process, decision dominance on the future battlefield will allow our soldiers to rapidly counter and adapt to our adversary's threats. Small unit resupply does this with the focus on emergency resupply. So the purpose of I already hit the purpose of the project, but today the capability that it has is basically to digitalize the process at the tactical edge of requesting resupply and then planning for that resupply all the way through execution and really accelerating that process. So today, a dismounted unit can request resupply using their phone over a tactical network. There are various services and personnel that are required to fulfill that request. So that signal, then that data automatically goes up, hits all the sustainment personnel. The sustainment personnel can then conduct pre-flight mission planning very rapidly with seamless information exchange across all parties, so everyone's aware. And then once you're done with mission planning, you can automatically transfer that data and task an autonomous resupply vehicle. So basically, you're accelerating through automation and pulling all the humans out of the loop. In the future, I think the thrust areas, so that's kind of current capability. In the future, I think some of the thrust areas we want to work at or capabilities we want to improve upon are basically to replace the manual request by observing in real time supply levels of the dismounted soldiers. Mm-hmm. So creating sensors that either are detecting supply or detecting consumption, right. and we generate supply levels from that. We can monitor that, and then upon low supply, we can automatically task a resupply vehicle to send out the supplies that are needed. With that data, it opens up the door then in the future to do kind of more predictive logistics, which is you then monitor supply levels over time. You can prepare for in advance an emergency resupply. So it's not an emergency. You just know and you're ready to resupply it before it's needed. In addition to that, I think we want to pull the human out of the loop more and start automatically, with decision dominance, you want to automatically start making decisions without training the troops to do so. So automating decision making is, I think some of the focus areas there are we're going to start working on automatically selecting a drop zone or landing zone, given the digital environment around the point of need, which is the person that's dismounted, and then choosing the right vehicle for the right mission, given the environment that the dismounted unit is in, basically digital environment, the terrain, the weather, takeoff locations, threat levels to aircraft, and that type of thing, and maybe electronic warfare threats. You can determine through a family of resupply systems, you can determine what vehicle is best suited for that mission and gives you the highest reliability of success, right? So that's, I think, what we're going after in the future, I think, for a small unit resupply.
Yeah, no, that's awesome. And, that's the whole idea of optimizing, using MET-T, right? Optimizing the vehicle based on, the parameters of the weather, the terrain, all that stuff is important. So one thing I want to talk a little bit about is, we talk about emergency resupply. So, this is similar to call for fire, right? For the artillery perspective, right? Hey, I need artillery here right now, and so that's a system that's been in place for a while. They call for it, artillery gets delivered fairly quickly. But you also can do pre-planned artillery, right? So you're going to do a mission from X to Z or whatever, and so the route, where you're going, planned engagement areas, so you can pre-planned target reference points is what we used to call them. And so I think there's an opportunity here too to probably do pre-planned packages for resupply. Like I'm a squad or a platoon. I know we're going to go out for 3 days. We're going to have potentially, based on the enemy situation and engagement, I know I'm going to have probably this historical usage or consumption. So I'm going to need this package. And having that maybe in the BSA somewhere, the brigade support area, already uploaded on a vehicle, just sitting there ready to go, that could be a huge advantage for us, right? Because then it's quicker than any emergency resupply. This thing's ready to go at any minute, right? Yep. Your thoughts on that? I mean, you guys thinking through that too?
Yeah, absolutely. So everything I kind of described with small unit resupply project was really focused on kind of digital information exchange, automation. After you have that information, you could do kind of what you're saying. The concept of what you're saying is the dismounted routes. Because of the adversary threats, you have dispersed operations that are moving in specific routes. You could have pre-planned resupply locations that are caching in advance of the person getting there because you're monitoring their pace and their location as they're going. And then you could have that delivered, and you could cache that supply before it gets there. Because there's going to be because of the threat level of the future, you're also going to have these dispersed operations. You're going to have lighter, more agile troops over vast distances. So that's going to also create an issue that they have to carry maybe less supplies or be more efficient for the agility. So the small unit resupply, sort of like you're saying, we would envision some sort of a dashboard that has each unit's objectives of their mission, their planned routes, their resupplied routes. You'll have a dashboard which shows you the demand now and then the demand in the future.
Okay, so this sounds like this is heavily dependent on the network, right?
Yep.
And so you guys are, from the squad level all the way up to where that final resupply decision on what kind of vehicle and what the package is, that's got to flow, because without that, it doesn't work, correct?
Yes, absolutely.
So the other thing I think that's important here, and you could probably touch on too, is the reliability of the process. Because if I'm a squad and I call for emergency resupply and it doesn't show up, 3 or 4 times, I'm probably not going to call again, right?
Yep.
So that reliability's got to be baked in, and I think that's incredibly important. But so when you guys talk about different vehicles, could you kind of talk a little bit about what you think the breadth and depth of those vehicles could be in the future, the delivery mechanisms, if you will?
Sure. So I guess in general, the vehicles that are developed, there's no one solution that can solve a problem, right? So there's never going to be a vehicle or a concept of operation that's going to work in every, aerial emergency resupply situation. So you're going to always have a family of systems. So you might have a family of, call them logistics quadcopters, that are doing that last tactical mile from your, from your closest sustainment element to the fight. They're doing the last tactical mile coming back and forth, because with the logistics quadcopters, you basically have a weight range problem. Low weight, low ranges, basically. So you want those as close as possible to the fight. From there, then you have going up the chain of command, but also going out in range and weight. You have bigger and bigger systems. So then you might have fixed wing systems that can carry what might be small unit, amount of weight over very, very long distances. You might need powered parachutes that then can hold a considerable amount of more weight, but they're low and slow.
Sure.
So you actually have, I think, a toolbox of a lot of different systems that all have pros and cons, and some of which work in certain environments and some don't. It even goes as far as we're talking about very smart systems that are autonomous, right? We're very focused on that, but those might give you the offset in the range, but to make them more attritable in the future, they need to be easily producible. They need to be simple. So once you go into certain timeline of a conflict, you could use your long range precision stuff, and then start getting into your ballistic high throughput means of delivery, which are more simple, cheaper, and easier to produce.
Now, you guys obviously focus mainly in the air domain, but there is a ground element of this, right, that we have to focus on too, with SMETs and other vehicles coming online. General Rainey is a huge fan of providing robots for small units, both for combat platforms, but also for resupply. And you can envision potentially maybe a small unit like a platoon, having a robotic vehicle that follows behind it, right? Autonomously, just understands where the unit's going, picks the best route. There is an issue, though, with security of those things. You don't want the enemy to get your supplies, obviously. But can you talk a little about maybe how we could integrate the ground platforms into this? And I understand that the only one available today is a SMET, and that's very immature technology today. And there's limitations with the ground, right? There's more obstacles. It's harder to get through terrain than it is over with the air vehicle. So
exactly. So because of our experience in our office, we are focused on emergency aerial resupply, because that's what we do. It's the same problem pretty much for the ground folks. I think their mission planning problem is a little different, where they then have to understand the limitations of each one of their vehicles, like the SMAT or any other autonomous vehicle that runs on the ground. Is you need to really understand the terrain, your route, and you need to route around terrain or rivers or obstacles and things like that. I think our project really wants to start focusing on aerial because it's what we do, but then we want to start teaming with like the SMET folks.
Right.
So we want to team with the ground side so that we can work on the aerial logic and determining the best vehicle there. But on the ground side, you really have to do a lot of ground mission planning. So if you're talking about land, you do the SMET or some other autonomous, vehicle. And then also on the maritime side, you're going to, in PACOM, you're going to expect that you're going to have autonomous
waterborne vehicles, both above and below the sea. Absolutely.
Exactly. So you'd want to team with them to actually select the real, in all domains, select the mode of transportation that you want. Our focus is the real tactical edge, which seems to be in sustainment. Like you said in the beginning, your sustainment supplies are going to flow down the chain of command, and then they just, the last tactical mile-ish or emergency resupply is where there's a little bit of a gap to get it out as timely as possible.
Yeah. So I guess the last question I have for you is just maybe not a question, but a discussion point. If you could talk a little bit about interaction with soldiers, the importance of that, and do you get to the field, as we go through this process, and how do we incorporate them to help solve this problem for us?
Sure.
For them, I should say, really.
Yep. Yeah. So interfacing with the soldier is absolutely critical. I think in aerial delivery, actually, in airdrop specifically, we've always not had a problem with that, and it's because we work in sustainment and logistics, and it's pretty much a low priority until it becomes the highest priority.
Right.
So we do have consistent access to troops. Example of this is, the first time our autonomous air vehicle was fielded. I forget what year it was, but it was a while back.
Yep.
The PM office, we rapidly fielded a system in Afghanistan when operations were at their height, and it really wasn't suitable for the terrain, and it wasn't suitable for soldier use with the level of training that they're used to.
Right.
So immediately after that, we just started, supporting contingency operations here from Natick Soldier Center. We started training the force as fast as possible, and really listening to their problems in Afghanistan each year. And each year we were incorporating them into design, rapidly fielded, and going over, talking to the troops on site, helping them execute their missions, and then taking the lessons learned and feeding them back into design. And then basically it kind of just evolved outside of Afghanistan once we moved more to all the combatant commands after that. With focus outside of that region, we just started applying our lessons learned about, suitability to the environment and the soldier to the designs that are happening today.
Yeah, you guys adapted incredibly during that time period. I mean, Rich Benny has a slide he showed me a long time ago, but it was basically how many tons of equipment and supplies were dropped into FOBs in Afghanistan, and I couldn't believe it. It was just phenomenal. It blows my mind how much and how accurate it was, right? And how they relied on it. And what a unique situation, because we had not fought like that probably since Vietnam.
Yeah.
And to have the ability to get supplies into unique locations, is challenging, but phenomenal job you and your team has done. So look, I want to thank you, Eric, for taking the time today to explain a little bit about small unit resupply and the importance of it for our future Army. And I want to thank you personally for, joining the workforce here. It's a great place to work, as you know. It's exciting. There's many different fields engineers or other scientists can get into here. But it all really comes down to one thing, is making our soldiers more survivable and lethal in the battlefield. And so I want to thank you personally and your team. And any closing comments from you?
Nothing here, sir. Thank you.
Awesome. Thank you very much. Appreciate it.